before Wednesday, you want to do the extra work. So Bozeman Video will always have a video on each of the mandated labs. Pearson's Lab Bench also has a walkthrough. So there's like a little tutorial and it takes you through a dry lab and then it has some quiz questions at the end. So do those before Wednesday, just for yourself, for understanding. This is our lab. And rather than having you carry out the lab, I have put images in of many of the steps so that you could see what it was you were doing. A data set for you to work with. I've highlighted in blue the number, like where you need to fill something in. Okay, so we need to be able to work with the numbers. Again here. And then that's part one of the lab is usually like I give you this unknown colored solution and I come in and I'm like, oh no, I forgot to label my solutions. We got to figure it out. So you're going to figure out which molarity each of those solutions are based on how much change there has been between a dialysis tube. Let me scroll back up. Between the dialysis tube's initial mass and mass after the fact. Okay, so you're anywhere from 0 to 1 molar. Which one's going to gain the most mass, do you think? Which one's going to take on the most water? The greater the gradient, the more movement there'll be. So distilled water should cause the greatest movement. And which one should pull out the greatest amount of water? Knowing that solutes suck. 0.2, 0.4, 0.6, 0.8, or 1 molar? 1. Thank you. 1 molar has a lot of solute, so it's going to pull the water out. So relative to each other, you should be able to range them in an order from least to greatest or greatest to least to determine their molar concentrations. So day 1, we figure out what the molar concentration is. Day 2, we take those known molars now. We make some potato cores. We punch out little tubes of potato. We mask them. We put them in the colored solution for a day, and we mask them again. So I've given you the initial and final mass. You need to calculate the change in mass. Then we're going to graph that. This is a clickable graph, so you can add labels, data points, and a line. Or you can create your own in Google Sheets or whatever, and you can copy paste it into here, okay? We always use a line of best fit or a trend line. So if you're doing this like with Google Sheets, you would use what's called a trend line. But the line of best fit is like the line that most closely touches all of your dots. We don't go dot to dot when we draw our line. So if mine was here, 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 I'm probably going to go in between them. The point where your line crosses 0 is the concentration of that solution or that substance. It's not gaining, it's not losing mass, so it must have the same concentration as the substance, right? So anything up here, it's gaining mass, so it's sitting in a hypotonic solution. Anything down here, it's losing mass. So it's sitting in a hypertonic solution, okay? So if it's not gaining or losing, it's isotonic, which means it has the same concentration. So what you're doing is figuring out the concentration of the potato cells, okay? And then there's some follow-up questions. So Wednesday, I will have my Zoom open in case you need help with the lab. But that's basically it. You don't actually have to physically do it. You just have to work with the numbers that I provided you. Okay. Any questions on the lab? I also put in Google Classroom just resources to help you with content.